I'm from AVA, a company based here in Berlin with a large R&D office in Novi Sad, which is like half an hour, 40 minutes drive from Belgrade up north. And I'm here today to give you a glimpse into what we do at AVA, without actually trying to sell what we do, but actually like really trying to give you an idea of how things work, because whenever we describe what we do, there are usually some kind of questions coming up, and I'm really happy to have this presentation, which allows me to give you maybe a little bit of answers to that. It connects a little bit with what we just saw before. Like we have the notion and the ambition to create the safest world, or a safe world, a secure world, based on deep data and information. So the usual metaphor that we use, one of the metaphors that we use to explain what we do, is that we are kind of a weather forecast or meteorologists, but not for wind, rain, sun, and temperature, but rather for crime, terrorism, healthcare-related risk like epidemics, but also civil unrest and political risk, and all those kind of things that could actually affect like one's life or one's property. With a little bit of difference to what you just heard when we talk about facial recognition, this is not our field. So our system doesn't look at humans or at individuals. Our system looks at behaviors in general, and it looks at locations and things that are happening, so to say, in urban space, for example, or in organizations, but really without going to the point of saying, like pinpointing, oh, that was Thomas and that was Martina, but really saying, okay, there is something happening, and giving people who need that information in time. So we're addressing a couple of things with our system. So we talk about, as I said, crime and violence, but also public disorder, fire, vandalism, high-risk events, but also large-scale events, like when there's a huge football game taking place, it might have an effect on the security of a city or the security of a neighborhood, etc. And we work for police, for example, in London. The Metropolitan Police in London is one of our customers. But we also work in public transport, so there are a couple of public transport operators using our systems in their day-to-day operations centers to figure out like how the situation is, and when something happens, how to actually deploy resources to make the public transport safer and more secure, or large logistic companies who actually want to be in the know when something happens on the world that affects global supply networks and global supply chains. To explain it a little bit in a short version, and that's really simplified, of course. So our system looks to find incidents. So these are usual things that happen and people report about it, or we have sensors, etc. I come to that. But from all of these various sources that we are looking at, we try to figure out what is going on, and then we're processing this information. And for that, we are looking at a lot of different data sources. And one part of the presentation will be to give you like a quick overview of how that functions and how many things actually around us exist that allow us to see how the security of a place is affected or can be affected, even surprising things that usually people wouldn't even think about, which have an effect on security of our surrounding, or like of organizations. So one question that I'm able to raise since a while ago, there was this terror attack at the London Bridge, and then there was things going on in London, you may remember. So we have been able to see that happening 4 minutes before the traditional procedures and methodologies that the London police has been deploying before they have seen that. We know that because we during that time had a couple of pilot projects going on with several boroughs in London, and also with people at the City Hall that are responsible for crime and policing. And from there on, it was kind of clear that we would work together. So ever since, like, we're working with London Police and the City Hall to support them in the specific, very specific activities. So don't need to talk about that. But it's of course not related like to individuals or humans, but really about the security and the safety of the fabric of the city. And so the AVA Risk Score, which is one, if you want to say, like one of the core products or one of the core pieces of it, is looking at security and safety from a time-dimensional, time-space dimensional perspective, if you want. So we have the past security, or the historic a situation of a given location, like how is the statistic security of a place that can be relevant. For example, if you want to park a car there, and there is a history in that area that the park might get vandalized or stolen or something like that, and it would be good to know that there is such a situation. But also the present situation, like if there's right now an active shooter in Alexanderplatz, there are organizations and people that really need to know. They need to know right now and not read about it half a minute or even 2 hours later on the news. And then of course like the predictive part of it, like looking forward into the future, figuring out like actually what could happen. That is also a combination of the situation that we have now and the history. So all of these data, both the past, the present, and the future, they belong somehow together, because more or less like really like meteorologists, we can see specific contexts in a given space and figure out like, did we have such contexts before? Just to remain in the case of public transport, if we know, for example, that on a Thursday at 6 o'clock in the evening, usually we have issues on platform 8 and not on platform 4, and that has happened, like for the last 5 months, then it's almost common sense to say, well, next Thursday at around the same time, the risk for something happening on that platform is much higher than on other platforms. So we can actually use this data to go into like predictive modeling. What we do is context sensitive. So the idea here is that we are capable of individualizing the security and risk score not only to individual people, so it makes a difference whether I'm a woman or a man, or like whether I look like this or like that, or whether I have this religion or that religion. That is again like the part that we try to keep a little bit outside like of our focus, because there are a lot of things ethically related to that. But of course it makes a difference whether you're an old Peugeot or a brand new Bentley. Right, so also this like makes a difference. So we can integrate that and actually give contextualized security information. So again, like just quickly to round this part of the presentation up, we are designed by the principles that GDPR has been established, or that have been established through GDPR. So we've been working very, very hard to ensure that the system as such really brings no headaches like to our customers when it comes to privacy and data protection, which we believe is an imperative. Like particularly like with these technologies, if we're deploying them, if we are using such technologies to actually make the world safer, make the world more secure, cities and families and organizations, then there should be no doubt about like the fact that us related like to those kind of things. So with that, I would like to introduce you a little bit like to the way how we get the information and how we bringing it together like into one common system. So there are a couple of pools of data that we are accessing. The one piece of data, or the one pool of data, of course, is the internal data of our partners, of our customers, right? Like if, for example, a police has the history of 30 years of monitoring and tracking and documenting incidents in a city, then this data as such has already a big value to understand like what the current situation and the future situation is. But then, of course, internal data, for example, from insurances or from mobile network operators or from like organizations that actually have data that could be relevant for security. But then, of course, like sensors in IoT. I mean, we heard about cameras that can be used in various ways, not just to detect faces and understand who that person is, but also to detect behaviors. Right, on public places, for example. So to guide you a little bit like through the opportunities that are there thanks to data and advanced algorithms and advanced machine learning and all of these kind of technologies, one thing that is really interesting is that when we, of course, give our partners, our users the opportunity to also manually add incidents. Something happens, I know it, I can put it in. So by doing that more regularly, the system learns, of course, like, and if we have some specific patterns emerging all over through the time, then we can, of course, again, use this data to help to inform the situation. But then, of course, like also incident and risk prediction. So what you see here is like a photo that I took like from the screen of one of our data scientists. This relates to the data pool of Los Angeles police. So we took the crime data from around 10 years on an hourly basis. So everything that happened during the last 10 years for every hour of a day, for every day of the week. And we trained algorithms against that so that our algorithms would be capable of actually predicting the actual security for the day after or for the days to follow. So this is how we more or less approximate like our machines and our systems to understand from that amount of data, like what could be the outcome. And we are pretty precise already, which means we are running with an error rate of a little bit more than 5%. So, for example, if we predict for the upcoming day for a specific neighborhood 5 stabbings, or let's say 15 stabbings, then it will either be 15 or 14 or 16. But this is how close we are, like based on the information that we are using. Also, what is interesting that comes from the existing data sets is deep contextualization. The fact that we take information into account that is not necessarily related to security right away opens up to see things that all of a sudden seem to have a correlation or even a causation. So there is this very interesting research very recently published by the London School of Economics, where they found a pretty stable and reproducible link between air pollution and crime. Now people are arguing and discussing what is actually the reason why it's like that. Why is air pollution and crime so heavily related? And there are, you know, like tons of concepts right now going around. It could be something like a bigger broken window effect, you know, maybe you heard of that kind of concept. But it's a little bit like aspirin for us, you know, like we don't need to understand every time why something works, if it works, right? Like with, I don't know how aspirin works, I just take it and the headaches are away. And in this case, when I know air pollution goes up, petty crime goes up, that's enough for me to know, right? And we can inform based on that. So sometimes it's not even necessary to explain things that detailedly. Digital media monitoring is one thing that we do. It's pretty obvious, of course, you know, like people are posting on Twitter and on Facebook and on YouTube and all kind of media, and they're putting out this information. And of course, you can see when something happens. And after all, like when something happens in a city, in a day-to-day life, usually there's always someone who's the first eyewitness. And the question is, what happens with that information in the first situation, like when it happens? And in the past, people, of course, they ran like to the next telephone booth and called the police or something. Now they have smartphones, but they have options on their smartphones, right? So they can call the fire department or the police, but they can also take a picture and post it on YouTube and Facebook and Twitter and co. And unfortunately, or maybe even fortunately, depending like if whether police is using systems like ours, many people are actually using social media to actually get relief of the trauma that they're seeing. You know, like a building crashes. You know, like, and the first thing that comes to many people's mind is to make a photo. Right? And that is not because these people are bad, it's just because this is what we are used to. We wake up in the morning, we take the phone, we tweet, we check our feeds, all of that stuff. So in such a situation, we are not trained to do something else, right? Like it's very traumatizing, and therefore we find it kind of crazy, but also kind of understandable that nowadays, fire departments, without actually actively tracking social media, they're always lagging behind. You know, like people are posting pictures of burning buildings and flames high up in the sky, but nobody is calling the fire department because everybody thinks like someone else already called them, right? Like, and they're making photo and all of these kind of things. So for organizations like the fire department or the police, such things really become important. And like in this case, at the Munich Olympia Center, where we had the presumable terror attack, which was actually just one young man who you know, like behaved differently than we all expected, but I consider this really like being a terror attack as the way that for a minute or an hour or 2 hours, all of a sudden people were thinking, like, there were like this lady wrote there, you know, like a gunfire everywhere around Munich, even at Stachus, which was actually not the case. But all of a sudden, social media also becomes like a relief, like a vent, like a relief tool for people, like to somehow communicate. And we learned a little bit about these past events and how to actually detect fake news, for example. So one thing that even doesn't come like to on people's mind, but can you imagine, you know, like you're standing in front of an active shooter, or like an active shooting taking place, or a building up in fire? The last thing that comes to most people's mind is to invent a hashtag. So for us, in some cases, hashtags are actually a very well marker for us to know that most probably this is not an eyewitness, because the way how people are behaving in such situations is really different. Like they're using these type of technologies much differently than if you would simply do that to gain likes or gain awareness. So hashtags much closely related to someone trying to get awareness and get shoulder taps and likes, but no hashtags, more probably not someone who's actually thinking about how can I get more visibility on social media, but this is like really a different thing that is happening there. And this is also like what I wanted to speak about here, like really trust scoring and fake news detection, which became a really important part of our work, of our day-to-day work, like to really figure out how can we ensure that we don't inform like our customers, our partners about things that are actually not true or that are actually not real. And this is something that we try to deploy. Like that was just one example, but if you want, like we really have for each and every single channel that goes into AVA, we also have a trust scoring, so to say, up and running, which automatically checks out like whether a specific Twitter account, for example, is actually trustworthy. That can go even that far that we check how old is the Twitter account that had just posted this, and what are the connections of the Twitter account. Does the Twitter account have a picture? You know, like those kind of things that allow us to see whether it's a bot or, you know, like those kind of things. Something that we experimented a little bit, but which I'm also telling you to give you an idea of how broad the spectrum is, like how you can use such technologies and data without even interfering, like with personal data. Really, I mean, with personal data, is to look at network cells. Like what kind of behavior would we actually expect if, for example, at Alexanderplatz at 3 o'clock on a Saturday afternoon, all of a sudden the consumption of the key network cells are going low, and the network cells around it, like from the mobile network operators, have a much higher consumption. It at least tells us something about like how people are moving in this area, you know, like, and it's an unusual way of movement. And that is just today. We're not even talking about 5G and the low latency and high precision, which is, so to say, the thing that we are already preparing for. With that, we can actually see how people are moving through a city, and potentially also see anomalies that allow us to understand, okay, there is something now happening that is really an anomaly. People are running away from something, so what is there? So actually deploying further technologies and things to see. Something else that we tried out and which works perfectly, but not in Germany. In Germany, it's not allowed. If you do that in Germany, you go to jail. There's a Funkgeheimnis, you know, like even if you could technically listen to police, alone trying it actually gets you into jail, so to say. And in the US, this is not the case. We can together open up a website. There's a list of all the radio frequencies of US police and fire departments and emergency dispatchers, and we can listen like to police chasing bad guys in Miami-Dade County. You know, like, so there will be, you know, like all of that is freely available on the internet. You can listen to it like Spotify. So if you take a speech recognition service, you don't even have to invent it, right? You use some Alexa web service and transcribe what has been discussed there, and you figure out that they're even using structured language. You know, it's not like people talking with each other, but these are professionals using codes. You know, code 2 means go there, but without blue lights on. You know, code 3 is, you know, like how to behave, you know, like what kind of things to expect and what kind of incident has happened there. So we even get structured data, even though it's verbally structured data, but it's structured, so we transcribe it. And from that, we can use the same NLP, like natural language processing technologies that we use to parse Twitter content to figure out like where something happened and what happened. So that way we can even take the complete US-American map and map it out like with real-time data from emergency and police and fire departments, as simple as that, right? So it seems like in the first moment like science fiction, but this is something that you with a little bit of technical background and a little bit of time can actually do yourself, right? It's not really complicated. Something that is also really interesting is like ambient audio detection, also a source that we are looking into much deeper, which means, you know, like how does a train station or airport sound like when everything is okay? You know, like you record the Gendarmenmarkt here in Berlin for 50 weeks, and you will know what the normal sound atmosphere is on that place, and then you can run the real-time data against that algorithm that you have created, and all of a sudden you figure out that, oh, there are people are getting louder, and screams come up, and maybe even gunshots, which brings me to the next one, which is another technology. So not all of these technologies we develop ourselves, I have to say. We are, as AVA, more like a central nervous system where all of these data sources go into and are being contextualized. So in this case, for example, we're talking about a US-American company that invented an algorithm that works based on audio triangulation. It has been tested in Barcelona, so if someone in Barcelona picks out a gun and shoots at someone, then if they're in that specific area, the lamp posts are equipped with microphones, and because the sound waves travel at a specific speed, and if you have more than just one of these lampposts, you can actually figure out by how long it took for the sound to reach a specific lamppost where the shot has been fired. So that way you can triangulate actually the spot where the shot has been fired. And not only that, from the waveform you can detect which kind of gun that was. So it was maybe a Beretta, or it was an AK-47, or it was a Glock. So that way you can see from the data, this was not a police gun that has been fired, right? Like it gives you information like really in real time. It puts it on a map and allows you to deploy resources much faster than ever before. And then cameras, of course, like you just saw the awesome presentation around facial recognition and those kind of things, but this kind of aggression and detection is something that is really, really interesting. Like alone in Berlin, BVG, like the Berlin Public Transport, they have a tender out. I think they are deploying 4,000 more cameras in the subway system. They already have 10,000 of cameras, I think, but now there are additionally cameras being deployed. And if you think of London, it's probably the city with the highest rate of cameras installed everywhere. But these are technologies that work after the fact. So they don't help you when you are getting stabbed or getting robbed. It only helps the policeman to go there with a with a document from the judge to check out the camera that was around there, so maybe they can get evidence from it after the fact. It's not really helping in the moment when it's happened. So if you deploy computer vision algorithms that allow you, and I think there's a company also in the exhibition area that is actually doing such kind of algorithms. When you deploy such algorithms, you can actually, from the live feed, you can detect when something is happening. People are fighting, someone is running away from someone, someone is pushing someone. Those kind of behaviors that actually point to an aggressive behavior or to an abnormal behavior. And again, that gives you the time to really much quicker deploy resources and get people to where they have to be, or tell people to withdraw from that area because there's an anomaly. So those kind of things are possible, and they are only possible like that. Because if you think 4,000 cameras, which human should sit there and look at these camera feeds? Right? There's no chance for nobody to look at that. Plus, in addition, to check all the tweets that are coming in. Plus, in addition, to check out all the news media that has been posted, and to check all of the sensors and fire sensors. This is unhuman. It's impossible. But these people that are actually currently working behind the scenes to ensure that all of our societies and our lives are safe and secure, they are overwhelmed with this data. So they actually need something that allows them to put all of this information together and understand it in a much better context. And this is actually what is happening within AVA. So really wanted to guide you a little bit to some other things, for example, near repeat patterns. I mean, this is criminology from the 60s, right? So imagine tomorrow I go and break in your home, right? Or in your home, and I steal your computer and your TV in your home. So I steal all of your computers and all of your TV sets. And what happens next day? You're extremely angry. You had a call with the police, with insurance, and all of that. And the next step will happen. You will go to MediaMarkt or online and buy a new computer and a new TV set. So smart guy who's breaking into your house will know that, and they will return, right? Because they know you have a new TV and a new computer. So it's almost it's almost funny, they're like these bad guys. They're just coming to steal the stuff away from you, then to throw it away because they know a week later you will have the brand new Apple MacBook standing there, and then they return. So based on these kind of patterns, police is already working, right? So it's nothing really new here, but by adding additional information and things to it, there can be a lot be done. So what we do is we provide these operator interfaces. They're usually being accessed by situation centers, so in public transport or in police. So the people responsible for that, they look at that, they try to understand what is going on in their cities or in the areas that they're responsible for. But you will also say like buildings or locations and even insurances and underwriters. They say like we want to know like particularly like with bigger cities, you know, like if a Lloyd's insures the Olympic Games, you know, like they actually want to know what is going on there. Then you have like the field staff. Yeah, watch out, don't worry. Like the field staff, right? Like running around. Right now they're blind. Yeah, like they're being called like to a specific situation, and they arrive there and they know nothing, right? They don't know what this history was of that area. They don't know what is happening right there, exactly. And with that, we are actually informing them and giving them the opportunity. And this is something that we actually started with. The original idea was to say we give a security situation center to everyone, to every single individual. Right now we do that by an SDK. So if you know, like any company says like we want to deploy something like that, like a security and safety app for tourists or whatever, they can come to us and we can provide all the libraries and all the modules that are necessary to actually deploy something like that. But really interesting it becomes when you think about how this data can actually influence our day-to-day life. So I'll be really fast with that. But this is, you know, like I don't need to explain it. Like your car telling you you should not park here because it's unsafe because of potential risk of being stolen. Or even calculating the route from A to B. You don't want to end up with a 9/11 in a favela on your way to the airport in Brazil. Same goes for financial markets, right? Like those financial markets that tick very, very fast, and a bomb going off in front of Foxconn has an influence on the stock prices of Apple or of Samsung. But also tourism and travel, right? Who wouldn't want to have like a button to say, I want to narrow down like the hotels based on the security of the neighborhoods where they are. Because Fifth Avenue, yes, we know it's Tiffany's and Hermes and all the beautiful things in New York, but Fifth Avenue is also South Bronx, right? It's just a street that is very long. So if you might end up in Fifth Avenue, wanted to have like the luxury hotel and actually calling for an Uber, someone is pointing a gun to your head to get your smartphone, right? So with all this being said, I'm very happy that you took the time to take a little bit like a look on what we do at AVA. It's usually something that we don't do, like to be that open, but if you have questions or if you wish to have like a demo or something, just let me know and I'm happy to give it to you. Thank you.